Hi everyone, and thank you for joining me in this lesson. In this video, we are going to learn how to solve double inequalities that contain variable terms in all three parts of the inequality. If you remember from the previous lesson, we solved double inequalities where the left and the right sides contained only constants, and the variable appeared only in the middle. Now, those types of inequalities were straightforward because we could perform the same operation in all three parts until the variable was isolated. But what happens when there is a variable in every part of the inequality? You might be wondering, why do we need a separate method? Can't we solve it the same way? Unfortunately, the answer is no, and here is why. Suppose you want to solve this double inequality. So this is going to be the left part, the middle part, and the right part. So normally we like to isolate the variable and keep it in the middle part. So what that means is that we have 3x minus 10 in the middle, and we need to get rid of the variables 7x and negative 2x that are respectively on the right side and the left side of it. Now we know that in order to eliminate a variable term or any term, we have to perform the opposite operation. So if you have 7x plus 6 on the right side and we want to eliminate 7x, then we have to subtract 7x from all three parts of the inequality. Let's see what happens. So we're going to write all the sides the way we have and subtract just 7x from each part of them. Now, I'll focus in the middle. So 3x minus 7x is negative 4x. I have no problem with this. Minus 10, that's perfectly fine. I really like what this has turned into. So we have 7x minus 7x, 0x. So we have just number 6. And this is just what we wanted. And if you notice on the left side, we have negative 2x minus 7x, negative 9x. And then we have plus 5. So the left side of this inequality will have a variable term. And if you're thinking of isolating or removing or eliminating this term by performing the same operation as we did for the right side of it, then you're not alone, because that would be the immediate thought. But think about it, what happens afterwards. If you were to subtract, or add in this case, so subtract a negative 9 or add a positive 9 to each part, a positive 9x to each part of this inequality, then we are going to end up with, let me just do this, the whole thing. We're going to end up with just a constant term on the left side. So we'll have 5 in here, which is kind of nice. We want to have a constant. The middle will be 5x and then minus 10. But take a look at the right side. So now we're going to have the variable on the right part of the inequality. So it seems like we are going in circles and we're unable to bring the variable x right in the middle and only in the middle. So the method that works when we have constants in two parts of the inequality and variables in the middle, it's not working anymore. So what do we do in this case? Well, there is a solution to this, and what I'm going to do is erase this to make room for the correct way of solving this inequality. Now, in order to solve this inequality, we'll compare the middle expression with each part of it. In other words, we'll create two inequalities, two separate inequalities. The first one will be negative 2x plus 5 less than or equal to 3x minus 10. And the second inequality, which will be negative 3x minus 10 less than 7x plus 6. Now, remember that in double inequalities, both conditions must be simultaneously met. So this has to be greater than or equal to this, and in the meantime less than or equal to that. So what that means is that when you find the x values that satisfy this inequality and x values that satisfy this inequality, then we're going to say that the solution to the entire thing will be whichever x values work for both of them, similar to systems of equations. So let's continue solving each inequality. There is nothing new in this step. So we will simplify. These are simple linear inequalities. So negative 2x minus 3x less than or equal to negative 10 minus 5. I'm following the steps very slowly. You can do this in one step, obviously. And the next equation is 3x minus 7x less than or equal to 6 plus 10. Okay, so let's simplify a little more. Each equation now will become the first one, negative 5x less than or equal to negative 15. And the second one, we have negative 4x less than or equal to 16. Oh, these are very nice numbers. So one more step to go. We'll divide both sides of these inequalities by the coefficient of x, respectively, obviously. So divide by negative 5 every term in the first, by negative 4 every term in the second inequality. And as you can see, in both inequalities, we are dividing by a negative, so the directions of inequalities will change in both of them. So the first inequality will be x bigger than or equal to 15, negative 15 over negative 5 is 3. And the next one will be x. Now you have a bigger than or equal to, remember the inequality direction will change. 16 over negative 4 is negative 4. So now let's place these solutions on the number line. It makes it a lot easier. So we're going to spot where number 3 is, positive 3. It's right here. We want the values to be greater than or equal to 3. And those numbers are all here. Now we have to determine all the x values that are greater than or equal to negative 4. So we want to include negative 4. Sure, why not? And we're going to say that all the solutions will be right here. Now we have to decide what the solution would be for the entire double inequality. And we said that the solution will be what works for both inequalities that we just solved. And as you can see, the two sets of numbers will overlap starting from 3 to infinity. So in set notation, we're going to say that squiggly brackets here or braces, XCR, such that we're going to say x has to be bigger than or equal to 3. And in interval notation, we're going to say that x belongs to the set of numbers starting from 3 to infinity, round brackets around infinity. We want to keep 3 in, so square brackets, and this would be the answer. Now, in the same way, you can practice the next example on your own. I'm going to continue the solution in here. Feel free to do this independently. So again, you have a double inequality and you have variables in every part of the inequality. Even if you had a variable only on one part of the inequality and you had a constant here, this is the method that we would have to follow. Because now, for x minus 9 less than 7x plus 3, and the second inequality would be 7x plus 3 less than or equal to 10x plus 18. Simplify. Now, 4x minus 7x, negative 3x, less than 3 plus 9, 12. And next we have 7x minus 10x, negative 3x, less than or equal to, we have 18 here, subtract 3, 15. Isolate x from both of them, divide by negative 3. Remember that both coefficients happen to be negative here. And we have x greater than negative 4. And down here we have x greater than or equal to negative 5. So greater than negative 4 means that we're going to go at negative 4 here. empty circle, exaggerate it a little bit. All the numbers greater than -4 are here, and greater than or equal to -5 will be right here. Fill the circle. Greater than or equal to -5, and will be all these numbers in here. So where do they overlap? They will overlap right here, starting from -4. We can't include -4 because it's not part of the first inequality. So if it's not part of the first, it cannot be part of the entire inequality. So we'll say that in set notation, x is any real number such that x is greater than -4. And in interval notation, we're going to say that x will start from -4. Sorry, here we go. Starting from -4 to infinity. And this will be the answer to this inequality. Now, I want us to go over one thinking question about inequalities. They're not that difficult to deal with. So in this question, we have to create an inequality given that this is a solution. And we want to include a constant and variables on both sides. Now, we're going to base our our thinking process in here on the fact that the solution itself is an inequality. So we're going to start off with the solution. And if you want to make a fancier inequality, then as long as you do the same thing to both sides of it, then we should be fine. So if we want to have variables on both sides, then you can add variable terms to both sides of this inequality. And the inequality still holds true because we've said before that in an inequality, you can add the same term both sides and it still remains the same. Now, if you want to have constants as well, let's simplify this. This would be 3x less than -2 plus 2x. So if we want to have constants on both sides, then you're going to say, well, let's bring some constants to both sides. So I'm going to bring -100 to both of them. And let's take a look at our new inequality. It looks fancier. 3x minus 100 less than 2x minus 102. And this is how you would build an inequality. Now, in the next one, what we have is create a double inequality with a given solution. In principle, we do the exact same thing. So we're going to start off with the solution itself, which is an inequality on its own. And then if we want to bring or make this inequality a little bit fancier, then we can just add and subtract the same terms or subtract the same terms to all three parts of it. So if I want to bring variables everywhere, so I'm going to bring, let's say, for example, 2x everywhere. And if I want to bring constants to all parts of it, then I'm going to bring a constant. Why not? The middle part didn't have a constant. And now our inequality looks like 3x plus 1 in the middle. And then we have 2x minus 3 on this side. And the other side has 2x plus 6. Not too difficult and a little bit of fun. So this was the lesson on the end of the lesson on inequalities, linear inequalities. And this is lesson U1L11A. So in lesson B, we're going to look at polynomial inequalities of degree 2 or higher. As always, thank you for learning with me, and bye for now. See you next time.